The topic is logistic regression. Okay. So, yes, when I say logistic regression, most of you must be thinking that it is a regression type of a model, right? We are going to perform regression here, right? So, when we say that we are going to perform regression here, it's not the case. It is the logic of regression which we are going to use, but we are going to deal here with the categorical type of data. Getting it? Or I'm trying to say? Let me repeat that once again. Just a minute. Give me a moment, okay? We'll be starting this. Logistic regression, which means we are going to work on the regression type of data, right? Most of you people, let me give you the quick revision. What is the regression type of data? The data which contains, you can say, continuous type of value in the target feature. Everybody knows that since we dealt with logistic regression, linear regression, multiple linear regression, and polynomial linear regression. We have covered all of these. Okay. Also, if you guys remember, we covered one classification type of model as well, right? In the classification type of a model, your class could be of two types. Binary, which means it is going to contain either yes or no, or multi-class. It can contain n number of classes as well, right? Like blue ball, green ball, yellow ball, pink balls. Okay, you can have this type of classes in the target feature as well. So if you read this name, what it states, logistic regression. If you guys remember how regression works, whenever we talk about regression, it completely means that there is going to be one equation of line, y equals to mx plus c. We are going to have independent features available, okay? After having those independent features, the combination of those independent features amongst one another will help me to predict the target feature. Dependable one, right? Now we have some assumptions for, okay, let's say this is your loan amount. This is your applicant income. This is your co-applicant income. And here you are having target or loan status. Now you guys understand, whenever I use y equals to mx plus c, and we are giving numbers to the x or m or the c, you are going to get the answer as the numerical feature only, or numerical type of answer is going to be there, right? Do we agree? Let's say if I'm going to feed here loan amount, applicant amount, and loan, let's say co-applicant amount, it is going to give me the answer in the format of some number, right? Then how am I going to judge this number as the categorical feature? That is the biggest question, okay? Because you are feeding your equation with so many numerical features which all are independent in nature. Are you guys understanding? The foundation is same. It's just your target is getting changed. Previously the target was continuous type of a data. Now it is classification type of a data. Simple. Now, the main question arises when we are having y equals to mx plus c coming into the picture, we are going to judge the mx plus c equation. Here we are going to have the number type of a data, how we are going to convert that into yes or no for the loan status. For that, we need to understand there is a function called as sigmoid function. The spelling of the sigmoid function is sigmoid. It's very, very important, okay? Because most of the time while you guys are going to get the interview, this is the basic question they used to ask. What basic question? That when we are having the logistic regression, why it works for the categorical type of data. This is very popular question, okay? Most of the time in the interviews, I've heard these type of questions coming into the picture, okay? Since the name is logistic regression, why it solves classification problem? Then you have to tell them that it is logistic regression because the property and the foundation of finding the target feature. Just a minute, guys. Give me a moment, okay? Yeah, I hope you can hear me. Yes. Come back to the point. We were talking about that how it solves the categorical type of problem. So you have to tell them that the foundation of this is the same as that of your linear regression that we solve. We are going to solve this with y equals to mx plus c. But y, since it is going to be all fed with the numerical type of data, the y is also going to be the numerical. Then how we can change this to the categorical type? It is with the help of sigmoid function. Now, what does sigmoid function actually does? It converts your, let's say, y equals to mx plus c, you are getting some value here as 210.88. For example, just assume it, okay? Now, what sigmoid function will do, it will convert this number into the probability. We will see the equation, don't worry. It will deal this as a probability factor, and you guys know that the probability range which we are having is always between 0 to 1, right? That you are not going to have the equation, or let's say the number more than 1 or less than 0. So suppose you are having the probability somewhere as 0.4. Now here you need to understand the rounding of scheme comes into the picture. What all thing we have done? This y equals to mx plus c, we are having the value of phi as 210. With the help of sigmoid function, I use sigmoid function probability and converted this 210 into some probability number of 0.4. Now, sigmoid function is such kind of a function that will judge your categorical type of data, which means it will draw a line somewhere in the middle and states that we are having the mid probability line as 0.5. Now, this sigmoid function or y equals to mx plus c will create a line like this. Okay, a bended one. Now, whatever probability coming below 0.5, we are going to consider that as 0 category. Whatever probability coming above from 0.5, we are going to consider that as 1 probability. You can also state this 0 as no and this 1 as yes. How this is happening? This is happening all because of sigmoid function, because it is converting your target number with the help of probability into some probability number or probability likelihood, which you can do the judgment, or with the help of which you can do the judgment that your category is going to be either 0 or no, unless 1 or yes. Okay. Now you will ask me that how it is going to deal with the multi-class type of data, right? As of now, it is binary type of classification where we are having 0 and 1. What about multi-class type of classification where we are having 3 or more different type of features coming into the picture? For that, logistic regression has poor performance. I have given you the brief, right? That sigmoid function will help you to convert your numerical number into the probability. But how? Understand that it is a mathematical function and it helps for the mapping purpose. Okay. So whatever your predicted value is, it will map that up with the help of probability. Predicted value mapping using probability. probability. Okay, this is the first point. Okay. So actually what happens is whatever your real value is, or let's say whatever your predicted value is, it is going to map them up between the range of 0 to 1, and we consider that as the probability. Okay. Since why do we call this as the sigmoid function? Because the curve it creates is in the form of S kind of a structure like this. As I have shown you already, that this is the 0.5. Okay. Now you will see the 1 is going to come somewhere here. Okay. The 0 is coming already here like this. Now, if I want to draw the curve, it is going to be somewhat like this. Okay. You know, guys, either the value could be 0 or it could be 1, right? Then, why this S kind of a structure is coming? For the threshold purpose. Because, as you guys know, that there is a possibility that the values can come here as well, here as well. Later, we can round them off. Okay. So, it will create a structure like this, and we call this as S kind of a structure or S curve. Okay. So, you can consider the value of y here, since it is y-axis and it is x-axis. Value of y here could be 0.3. This is your threshold value. Okay. Why threshold value? Because after this, your every value gets changed or gets decided. Either it could be 0 or it could be 1. So this is your threshold value. Consider here the value of y could be 0.8 or 0.9 something. And this is your S curve. Okay. So this is how your sigmoid curve is going to look like. Okay. Basic. Very basic. Any question? Are we good till here?
Yes.
Okay. Now, what are the assumptions for the logistic regression? That is the good question. Okay. I'll give you this whole whiteboard. I'll download this and I'll give it to you. Okay. Don't worry. Let me just write it down every basic point here. So what are the assumptions for logistic regression? Let me write it down. Assumption of logistic regression. Now there is one good question from my end to you guys. What is that good question? What is the error metric of logistic regression, guys? Let's talk about that first. What my error metric is going to be here? Looks like, what is your target feature looks like? When your target feature is categorical or classification type of feature, your error metric is always going to be confusion matrix, okay? Basics, guys. Now, whenever your target feature is of regression type, then you can pick up the matrix as RMSC, MSC, or MAE, SSE, things like that. Okay, do not forget this thing. This is very basic. Okay. Now, what are the assumptions which we need to keep it in our mind while applying the logistic regression? The assumption number 1, that your target feature should be categorical in nature. Very basic, guys. This is the already predicted kind of already known thing. Okay. So let me write it down. The dependent variable must be categorical in nature. Okay. This is your first assumption. What is the second assumption? The independent variable should not have multicollinearity. multipolarity. Okay, let me just, yeah. So these two are the assumptions of the logistic regression. What do you guys understand from multicollinearity? If I ask you, multicollinear, that's if something is or some features are multicollinear, what does that mean? Correlation. Okay. So in other terms, you can also call that as correlation. Simple. Okay. Okay. So what we can do is, let's take quick. That was writing logistic regression. Okay, importing the data set. Import pandas as PD. PD.read CSV. Information. And the name of the data set. Okay. So I read is the main part which we need to understand. So this is the data set. Let's see how the data set is looking like. We are having 400 rows and 5 columns. We are having user ID, gender, age, estimated salary, and purchased. Okay. Now, since this purchased is already written in the format of 0 or 1, it could be in the yes or no format as well. No issues. Okay. Now, user ID, gender, age, estimated salary, and purchase. The question say that the case study says that the data set given is the data set of the users. Okay. Usually the users like you and me who are very actively in the social media websites. Okay. Or applications, let's say Instagram, Facebook. Now you guys must have noticed that whenever you open your Facebook or Instagram, there are so many sponsored advertisements, right? Now let's say Raghuram is very interested in buying a new SUV. Okay. Now he's rethinking. I should buy or I should wait. Let's say the waiting time is too huge. There is a possibility that after 1 year I might be getting the same SUV with less amount. Okay, so he is having so many thoughts in his mind. Okay, but at the same time he tries to use the social media. Now what happens whenever you see the thing which you try or which you are manifesting to buy, you always click on that advertisement, right? Basically that happens. And if you are looking into the new dress, new or maybe heels, makeup, cosmetic, car, whatever it is, you try to open that website at least just to check what is the cost price, what is the on-road price. Okay. So people like you and me, we are using social networking application and they are having the data of people like us who clicked on the website. Okay. Now we are trying to predict of all the people who clicked on that particular advertisement, who wants to buy the new SUV car which the company has recently launched. Okay, let me write it down in the format of a case study or a question, because in near future, if you guys want to come back and read that, that will help you. Okay, so data set contains the information of various users obtained from social networking sites. Okay. There is a car making company that has recently launched a new SUV car. And wanted to check that users from the social networking websites are going to buy that SUV or not. Okay. While reading the question itself, you understand that we are having the target column available in the classification format. Very simple. Okay. Now we are having the data set. We are having the case study question available. Okay. Now you guys need to understand which all feature we need to select. Okay. User ID, selection of user ID is completely waste of time because it is just a random set of numbers, will not help us to explain anything or find any pattern in the machine learning. Meanwhile, we are having gender. Gender is male and female, right? So I cannot decide on the basis of male and female who is going to buy the car. Right now, we have to be pretty much related to the real world and we cannot go gender bias in that case. So I'm dropping that particular column, okay? Because even if I'm going to perform encoding in the gender, either I choose one hot encoding, it is going to be somewhat like this, okay? Or I choose ordinal encoding, it is going to be somewhat like this. I want neither of them to be there in my data set, okay? Because based on the gender, we cannot decide that they are going to purchase the vehicle or not. There is a possibility that Shivani can also buy a CV vehicle, right? Also, there is a possibility that the users who are clicking on that particular ad, most of them are women only, not men. So we cannot make decisions on the basis of that because it will somewhere turn out to be the biased one. Okay. So age, of course, it is an important factor because you guys know that we have some age bracket or age limitation for riding or driving some vehicle, right? So we need to understand that age is going to be very important factor. Let's say if I'm 10-year-old, right? And I want to drive an SUV. Of course, I can drive, but I don't have license and that is going to be illegal. Okay. So age is going to be an important factor and estimated salary is again going to be an important factor. Let's say I am 32 years old and I earn 0, right? Regression operation. We have to distribute this data set into the X and Y. But before going in that direction, guys, there is one thing which we need to understand. Guys, can you see there is any sort of problem with this data set? What do you think? Children. If I'm going to give this as the X, okay, and I'm going to give this as the Y, no problem. If I was solving this with the help of k nearest neighbor, again, no problem. But right now, I am choosing logistic regression here. In logistic regression, these two features tends to be independent, right? Also, they too are independent amongst themselves, but they are the responsible features for the prediction of my dependable feature. And my equation is going to be somewhat like this. Y equals to B0, B1 X1 plus B2 X2. We are having coefficient associated with X1 and X2, right? Do you understand one thing? If I'm going to have a larger value here in the estimated salary and smaller value here in the age, it is going to create problem while calculating the coefficient. Since it is the basic equation of line, right? We understand that. If I'm going to give the higher value, the coefficient will get higher. If I'm going to give the lower value, coefficient will get lower. Since you are applying logistic regression, there is a possibility that it will treat higher value the highest one, the lower value the lowest one. There is also a possibility that I am 20-year-old, but I earn millions, right? So what will happen? It will treat 19-year-old as the small value, and it will treat million as the large value, and it will not even try to create a pattern between both of them. Okay? That is the issue. which we are going to encounter here with the data set. Why? Because we are going or moving forward with the equation like this. Okay, where every feature is participating equally for the prediction of the target feature. Am I making some sense that why it is a problem? Getting the point, guys? Yes, no, maybe. Let me make you understand once more. Okay. You guys remember we talked about k nearest neighbor, right? There what we were doing, based on the loan amount, we were trying to judge that the person is going to get granted with the loan or not. Okay. There the loan amount and age were again two features. Okay. So in that case, we were not having any sort of problem. If you guys remember the example of k nearest neighbor, which we had discussion over the PPT, right? So in that PPT, you guys must have seen that we are having one column of age, we are having one column of loan amount, and the target feature was the person is going to get the loan or not, right? Now, do you understand one thing? In the k nearest neighbor, we were finding the nearest neighbor while judging the distance of each point. There, those two features was not related for finding the target feature. We were just finding the distance and they were equally participating. There, my higher value, my machine will not treat as higher. My lower value, my machine will not treat as lower. But here, when we talk about logistic regression, where we are taking the equation of line into the consideration, we have to think about one more thing, that we are having greater value, we are having smaller value. And in this case, there is a possibility that a 20-year-old person may be earning millions. Let's say he or she is an influencer, right? Now, you guys know that influencers are earning more than people like us, okay? He or she might want to buy that SUV, okay? So what will happen? The age my machine will consider as the smallest number because it is 20, because we are having the people with age 35 or 40 as well. And it will consider the estimated salary of that person, which is a million, as the highest value. Now, the pattern creation will get disrupted here. Okay? It will not be able to understand. One time we are having smallest value, another we are having largest value. Whatever it is going to predict in the Y, there is a possibility that could be disrupted type of value. Getting it? It will unable to identify the pattern, because there is a possibility we can have exceptions, right? We can have the 60-year-old person and he also wants to buy an SUV, maybe for his kid, right? So such type of possibilities are going to be there in this data set. And we cannot ignore this equation of line while predicting the target feature. Since we cannot ignore, then we have to keep this in mind that the features, those two independent features which we are picking right now for the prediction of target column will create problem for me. Now, what's the solution? What we should do? Can we do something in such a way that it will standardize all the values, which means it will follow some standard rule so that this value will not look small, neither this value will look large. Keeping all of them in that scale where the data is same, but you are applying two different algorithms. We will see what accuracy we were getting there and what accuracy we are going to reach here now with the help of logistic regression, right? That will also help you to do the judgment which model is better. Okay, so the main or sole motive here is that since I'm going to feed this data inside the equation of the line, we have to be pretty much sure with this that I cannot contain the data with the greater value or the smaller value combination because it is logistic regression. Okay, even if you are having the column like this one more, let's say co-applicant estimated salary, then it is fine. I can consider that even. But since we are having only two columns, it will create problem for me. Okay, because one value is very small, the another value in the another column is huge. Getting it? Now, is it making sense that why are we going to standardize it? Now, standardization, if you guys remember, I started the session with the topic of data pre-processing. Okay. So most of the time, once you'll be able to predict that it requires data pre-processing, you do. Okay. Most of the time, when you see that it is not done, it is not required, you don't do it. No problem. Okay. But I will show you. Once I apply this standardization, data pre-processing on this data set, you will see the increase in accuracy with less error. That is our sole motive. Okay. Now coming back to the point, age and estimated salary, we are having these two features. We are having the equation of logistic regression. Let's talk about standardization. Okay. What is standardization? Why we are performing it here and what changes it is going to make in our data set. Let's quickly first separate X and Y. Let's quickly separate train and test, and then we will perform standardization, because we have to be pretty much sure that where to perform standardization on what columns, and in what columns I have to keep them sober, not to touch the values. Okay. Just a second. Sorry. Going back to the point, let's choose X and Y. Okay. So this is your X feature. Even if the data set is same, the problem statement is different, guys. So you can consider it. No issues. 2, 3. And that's what I pulled this data set from the Kaggle. Okay. It's not the same one which I had. So 2 and 3, which means 0, 1, 2. 2 and 3 are these features. And Y I'm keeping as data set dot ilog all the rows and the last column dot values to convert that into NumPy array. So my data set is not going to be there, DF. Bad habit. Okay. So this is the, what you can say, X and Y which we are choosing. Okay. Now we know how we can train, test, split this. Let's do that at least. Next thing I'm going to do is train, test, split this. Okay. Splitting the data set into training and test. Okay. So simply writing from sklearn dot model selection import train test split. Okay. Cross validation score now. Once this is done, then simply xtrain, xtest, ytrain, ytest equals to train test split. Inside that, your X and Y data, the test size you can keep as 0.3. I'm keeping that as 0.3. Test size, it is going to be there. Random state as any number, any random number. Okay.